But then all of a sudden, stuff gets weird when you start postulating multiverses
Yeah.
to account. And the whole reason that I've heard people do the multiverse theory is because the purely mathematical odds of life arising on our planet by chance are effectively zero.
Effectively zero.
And so I just want to pause for a moment and ask people to consider what's being said here.
Okay.
You have evolutionary biologists saying, well, we can't explain the origin of life. So what we're going to do is we're going to postulate an infinite number of multiverses for which we have no real evidence whatsoever beyond mathematical reasoning, maybe, if you want to be charitable. And we're going to pin our hopes for the meaning and nature of life on that. And I just have to ask the question then, how is that more rational and reasonable than belief in a God who's revealed himself, a God whose character is reflected in the order of the universe because it is orderly, and who has a consistent testimony about himself that he's revealed to humankind, which has been vindicated again and again and again? I can't help but ask the question, who's delusional here?
Yeah, let's believe in the irrational to avoid the obvious. That's essentially what we're boiling it down to here. And DNA is one of those things that will drive someone to those extremes because it cannot have evolved. It cannot. There's nothing in science anywhere to indicate that DNA is going to come out of a primordial soup and become functional with all these integrated components for life to exist. We just started.
Well, it's like anytime we see information, it comes from a mind. DNA effectively is information. I mean, it's coding.
That's the first half of the argument.
Yeah, and we're kind of just at the halfway point of this discussion, too.
Yeah.
We've just been talking about the problems with origins and how it doesn't work.
Yes.
So, for the sake of argument, let's just say life starts by chance.
Okay.
We have living things now to work with.
Okay.
What's the problem with evolution then?
The problem is that you can't maintain DNA in living systems for millions of years. Just period. That's the argument.
Okay, why not?
Because of chemistry. Because DNA keeps on breaking down. So yeah, we have these exquisite DNA repair enzymes and systems, but they're not perfect. And mistakes slip through. Those are called mutations. And mutations almost always are bad. Occasionally there's a mutation that might be beneficial in a limited environment. Like in Central Africa, in the presence of the malaria parasite, it's better to be a carrier of sickle cell anemia and be sick than to be dead.
Okay, and sickle cell anemia, what does that do?
It causes the hemoglobin, the red blood cells, to form crystals. And that tears apart the malaria parasites that live inside the red blood cells.
So you have basically a resistance to malaria now,
a resistance,
but it's a mutation.
It's a mutation, and it's not good. Without the malaria parasite, you are at a significant disadvantage if you have sickle cell anemia. Even carriers aren't as healthy as people who don't carry it. So you don't want it. But in the context of, hey, I'm going to be dead from malaria before I'm 10 years old, or I can be a carrier or a full-blown sickle cell anemia, that's a good thing in that context.
Right.
But that's nothing to do with evolution.
Okay.
Because it's a downward change. Most mutations are negative. A lot of them are almost neutral, but then you're looking for ones that actually have an effect on the organism, and when we find them, almost all of them are bad. So how does evolution work in that case? If everything's going downhill, the very rare beneficial mutation can overwhelm all the negative ones? Not according to math.
And here's the thing too, is people always say that they want to just look at the evidence and see what it's showing. They want to set preconceptions aside. Okay, the evidence is showing that genes are falling apart, is what it sounds like you're saying.
Yeah, when we look at like humans across the planet, we can look at the letters that we carry. And there's about 10 million variable positions in our genome that are shared amongst all people across the planet. They're showing us we came from a single population, right? Adam and Eve, very clearly. But when you look at what's missing, there's deleted genes. Because we have 2 copies of each chromosome, if one part's deleted, usually everything is fine because you have a good copy left over. So deletions happen a lot. The deletions that we see there are millions of them, but they're different than the different populations, meaning that we're falling apart since we were a single population. Our DNA is being deleted. It's literally getting erased over time. Well, if that's true, then how can evolution be true? Because you trace back millions and millions of years, and you have so many holes in your genome that there'll be no way for an individual to find a spouse or a mate that has the complementary missing parts. Mm-hmm. As they build up and build up and build up and build up, extinction is guaranteed. And we see that in the human genome.
And it's happening right now. We're observing it, and there's not really an explanation then for how this fits in with evolution.
Yeah. So deletions show us we fall apart too fast. Generalized mutations, there are a lot of very rare mutations in the human population. Like they're only in you, they're only in your family, only in your tribe, only in your country, and the more spread out they are, the earlier they happen in human history. But they're building up and building up and building up and building up, and it's inexorable. We can't stop it. That shows us that evolution is not possible. Species cannot have been around for millions of years if bad mutations are constantly building up. No, you have to have natural selection has to be able to remove the mutations as fast as they build up, or species go, ew, and they die.
And that's happening too with things like, I think we've talked about this before, like the cheetah.
Yeah. Cheetah is a special case because there aren't many of them. Mm-hmm. But because there aren't many of them, there's lots of inbreeding. In the individual, between Africa and India where cheetahs exist, they're broken up to little pockets. So now it might be 10,000 of them in the wild, but each little pocket is its own little inbreeding population. So they're split up into isolated pockets and they're falling apart. In other words, each little pocket is a tiny little population with lots of inbreeding. And so the mutation rates are going up, litter size is going down, reproductive incompatibility between mates is plummeting. Cheetahs in the wild are probably going to go extinct because there aren't enough of them. It's a massive problem that happens on a short term. Now, larger populations, it takes longer for that to happen, but it still happens. Mm-hmm. If mutations are building up over time, then all populations are doomed to extinction, including humans. Therefore, evolution isn't true. The human race has not been around for millions of years, or we would already be extinct.
Yeah, and the problem gets worse, though, because I've heard you talk about, I think we've actually talked about a little bit, the out of Africa model.
Yes.
And how that puts forward that there was a very small population of humans for a very long time.
Yes, a massive problem. So the model goes like this. We had Homo erectuses on the earth, about 1 million of them spread out on the earth. And then a small population in Africa, or the African population shrunk, either way, of about an effective size of about 10,000 individuals. And during what's called a bottleneck, during a very long time, and I'm never told how long that is, but it's 100,000 years or so, that much inbreeding of that little teeny population allowed Homo sapiens to evolve from Homo erectus. Mm-hmm. But that little 100,000 or 10,000 population is going to be broken up into little tribes, just like the cheetahs.
Yeah.
How did we evolve? I mean, now we can fly to the moon, and back then we were banging rocks.
Yeah.
How did we become a superior species, intellect and ability and all these other things during a bottleneck that should have driven us to extinction? The number of mutations should have risen to the point where we just all died out. And that's the basic out of Africa model.
And we have that case study in the form of the cheetahs. And
yes.
that's over, I don't know what the death rate of cheetahs or the decline of the cheetah population looks like, but that's looking at a bottleneck over a course of maybe, call it 100 years.
100 years, maybe that. 200, yeah. Yeah. Now do it for 100,000 years, but it's even worse. Because humans have very low diversity across the planet, that's one reason why they had to invoke a bottleneck. Because when you have a small population, you lose a lot of genetic diversity. And we don't have a lot of genetic diversity, but they've postulated recently, some big name evolutionists, an earlier bottleneck about 1 million years ago, where we got down to 1,200 adults for 100,000 years. What? That's called extinction.
Yeah.
You can't have, that's one, total aside, that's one of my arguments against Bigfoot.
Okay. I would love to hear about that later.
Right now, you can't have a
this
slow
would be
growing,
possible.
slowly reproducing vertebrate species with only a dozen individuals for hundreds of years. No, there's no Bigfoot. You need 10,000 of them at least, and therefore we would find them. You're not going to have an elusive little, hiding over here, one or
Bigfoot
two
debunked.
individuals. You can't maintain that.
You heard it
You
here
can't
first.
maintain it in cheetahs, and you could not have maintained it in humans during this hyper bottleneck a million years ago, let alone the Africa bottleneck 300, 400, 500,000 years ago.
Okay. So I do want to point people to what biologists are saying, though.
Okay.
They're saying that a relatively short time ago, there weren't that many people on the planet, and we see very rapid expansion and diversification.
Yes.
Well, maybe not diversification relative to other organisms.
Yeah,
but,
just a little bit.
yeah,
little
but
bit.
basically a rapid population expansion from a very small point. And I know in your mind, that's pointing directly to something else.
That is exactly something that the Bible predicts. We started with a small population, Adam and Eve. Now, it's not just Adam and Eve's genomes, because God could have engineered different genomes into Adam and Eve's reproductive cells. So the amount of diversity in humanity might depend upon how many children Adam and Eve had. But then we had 1,1600 years later, a bottleneck at Noah's flood.
Yeah.
Where the whole earth got down to 8 people on board the ark, but Noah and his wife really don't count. It's like all people today trace back to Shem, Ham, Japheth, and their 3 wives. So the amount of genetic diversity in those 6 people dictates how much genetic diversity we have in the world today. So yeah, not much. And the evolutionists say, not much. Oh, that's really funny. That's exactly what we would predict. And a rapid expansion from there. Yeah, that's exactly. When you look at the Bible and you look at the children of Shem, Ham, and Japheth, they had 16 named sons from those 3 fathers, which you expect about 16 daughters also. Now they're all spread out in time, but if you went from 6 people to 32 people, that's a really rapid growth rate.
Yeah.
And so the human population would just go whoosh. Now we have 8 billion people today. That's trivial. From 6 people to 8 billion in 4,500 years is easy. We actually have to slow down the population growth rate.
Huh.
So the evolutionary story is modeling the biblical story. And it's not only that, the evolutionists claim that there's only one male ancestor of all people alive today.
I've heard this. Yeah.
Yeah, Y chromosome Adam. And one female ancestor of all people alive today, mitochondrial Eve. That's a direct biblical prediction. That's not necessary in evolutionary theory. They don't
didn't know
need
that.
that.
Not at all.
Not at all. Because if we split from population with chimpanzees, you'd expect a diversity of Y chromosomes and diversity of mitochondria. Then over time, that diversity should continue. But no, there's only one. So in their model, they have to invoke this bottleneck to explain how this diversity of Y chromosomes got reduced to 1. And the diversity of mitochondria got reduced to 1. But that's the biblical starting point.
Yeah.
So in many ways, what the evolutionists are discovering about DNA models the biblical predictions in the biblical story. Wrap that up with, you can't start DNA in the origin of life scenario, and you can't maintain it in a long-term evolutionary scenario. And the biblical story is shining brightly here.
Yeah. Well, another piece of evidence that people put forward that humans did evolve is they say humans and chimpanzees have very similar genomes from what we're seeing.
Yeah.
And that indicates we likely have a common ancestor. So how do you even begin to approach that topic?
My answer is it doesn't matter.
Okay.
Both sides are predicting similarity. Humans and chimpanzees look similar. So they should have similar genes for building their bodies. Okay? They eat the same foods. They, in many ways, act similarly. We have the same hormones even. So just based on that, what would you expect humans, from a creation perspective, what would you expect humans to be more similar to? A chimpanzee or an aardvark?
A chimpanzee.
A chimpanzee, duh. Yeah, so both sides are predicting similarity, but neither side could predict how much similarity they expected. Nobody knew until they sequenced the genomes.
Mm-hmm. And that just finally actually happened like a year ago, maybe, or so?
Yeah, a year and a half ago, we finally got a end-to-end, a telomere-to-telomere chimpanzee genome. But that was only 6 months after we finished the human genome. Remember, the human genome was finished in like 2001?
Yeah, I remember
it was finished
hearing
in
that.
2024. It was more than 20 years later when we actually finished it. And now
Yeah.
it's finished. We have a good human genome and a good chimpanzee genome. And when you compare them, yes, you can find areas, long stretches of DNA, they're like 98% similar. Great. But then there are areas with zero similarity. How do you calculate a percent similarity when you have a zero? There's a million letters chimpanzees don't have, humans have. What percent similarity is that? So it's actually a very difficult nut to crack. Yeah, when you compare the things that we have in common, high similarity. But when you roll in the things we don't have in common, that similarity is going to drop. And a letter for letter basis, 90% similar or less. On a comparison to comparison basis, 98%, 96% maybe. Fine. But again, no one knew what percentage was beforehand. No one could predict it. And both sides are predicting similarity. So it's a non-argument. It doesn't matter either way.
Because both sides are expecting to find what we found.
Because both sides are expecting to find basically what we found. High similarity.
Yeah.
So does it support common ancestry? Yeah. Does it contradict creation? No. Does it support creation? Sure. But either side, if it was only 90% similar, you know what the evolutionists would have said? Oh, we must have split 20 million years ago, not 6 million years ago. So they just would have backed the clock up based on the data. It's not a predictive engine. It's an ad hoc explanation that they said, aha, look at that. This proves evolution. No, it doesn't. It fits evolution. It doesn't disprove creation. It fits creation. Doesn't disprove evolution.
Honestly, I'm blown away when I think about like when I think about my body, you know what I mean? And how everything is works and how everything is so perfect. What also blows my mind, my mother had she had kidney failure, and she was on dialysis for a while. And when you look at the dialysis machine and you think that's the best it's this big, huge thing, and that's the best we can do as humans for an organ that's, the size of your fist. That's the best we could do. Our body is miraculous, right? Inside every single one of your cells, right this second, there's a molecular machine so sophisticated that our best engineers look at it with awe and humility, right? And we're not talking about simple complexity, right? It's specific. It's specific complexity. It's information, right? That's what I was saying earlier. Consider the DNA in your body. It's not just a molecule. It's literally code. It's coding. It's a 4-letter alphabet, ACGT, right? That quite literally contains the instructions for building and it's basically your operating system. 3 billion letters long. If you printed it out, it would fill hundreds of books, and it's packed with error-correcting code and regulatory switches and overlapping information so dense that we still don't fully understand it. It's insane to me. Right? It's not just random. It can't be. It's literally a language from our Creator, and it takes more faith to be an atheist. I do believe that, and they look at us like we're illogical, It doesn't make sense to me. I mean, I don't know. If this video made you think, please subscribe, like. This is a very small channel. It's something I do for fun because I enjoy talking about these things. I plan on getting the bells and whistles and editing a little bit better as time goes on, but I would really appreciate the support. There's a mathematician, David Berlinski, and he said that the idea that the machinery of life arose by chance is like saying a tornado sweeping through a junkyard could assemble a Boeing 747. Only it's infinitely more improbable than that. So here's the deeper question. If the universe is fundamentally information, rich, mind-like, and purpose-driven at the biological level, doesn't that point us towards a mind behind it all? Just like a book implies an author, just like a painting implies a painter, don't you think that creation implies a creator? No. Not even a little bit. I don't know. Um, a God who it's a God who didn't just wind up, the universe and walk away, right? I believe in a God who crafted living beings capable of knowing Him, loving Him, and reflecting His glory. When I look at the majesty of DNA and the elegance of cellular machinery and the miracle of a beating heart, right? I don't see just blind chance. I honestly do see the fingerprints of a creator. And the Apostle Paul was right. He said, for since the creation of the world, God's invisible qualities, his eternal power and divine nature have been clearly seen, being understood from what has been made. Biology literally coincides with faith. It's shouting creator, in my opinion, right? And like I said before, if this video made you think, please like and subscribe, and I'll see you in the next one.